So instead, what we're going to do is we're going to have a topologically correct address. Mobile devices.
Sure.
Yes.
So you're saying that we can't have that, right? Then that means every time we change IP address, for example, like in the case of like two users chatting with each other, like peer-to-peer sharing,
Yep.
this guy changes IP address because he was moving. How is this person gonna know that the IP address was changed?
That's the idea. What we have to do is we have to find a solution that's totally transparent. So this is kind of like anytime you have, like the internet, you can argue was not designed with mobility in mind, but everyone uses the internet. So we have to find a way for all of this existing infrastructure to still work, even though we want this to happen. We want, in the middle of a session, this guy to move down here. So the idea is we have to basically adapt the existing structure of the internet to do what we want to do. And the idea is to totally hide the complexity from the end users. The end user doesn't need to worry about it, so we don't have to, for instance, go and rewrite all the browsers and rewrite all the hardware drivers and rewrite everything so that this can happen. What we want to do is we want to find a solution that is compact and transparent. So we want, and that's what we're going to do.
Question over here. I was thinking, like, what if each individual class just kept track of the top level routers and then, just set their address like that instead of having to worry about each individual user, like just keeps track of those few computers that are some static IPs that, each map 10,000.
Okay. That could work. So what we're going to have,
I don't know how.
That is still a rather complex solution. What we're going to do is we're basically going to have, there's going to be an agent sitting out here with a fixed IP address that's responsible for keeping track of where you are. So it's kind of like this. When I was in university, I moved around a lot. So I would just give people my parents' home address. And people would mail things to my parents, and then they would package it up and forward it on to me. And that's exactly what we're doing here. So in that analogy, my parents are the agent who are keeping track of my mail, and they know where I am in real time, and they forward it on to me. So that's how we're going to solve this problem.
You said that we're going to keep the 1.2.3 address, and you're going to use a second address, which is going to be dynamic, right?
Yes.
But why do we need to keep the 1.2.3 address?
And that's so that the internet doesn't break. So for instance, or that's so that your session doesn't break. So for instance, let's say 1.2.3.4 out here is receiving a YouTube stream or something. So this will go on for half an hour, and then he moves down here. We want to keep that connection open. So as far as YouTube is concerned, YouTube is just an internet service, and so YouTube doesn't want to care about the fact that you're mobile. So YouTube just wants to deal with one constant IP address. So that's why you need two IP addresses. Okay, so we're actually jumping ahead here. Yeah.
So according to what you said, that YouTube is an application and it's actually working. It has to see a unique IP address on the device. That's what you essentially said right now.
Right. So as far as any internet service is concerned, I mean, there are specifications as to how internet services are supposed to work, and when you write your internet applications, be it YouTube or whatever, you depend on those specifications working the way you expect. And so what you expect is that throughout your session, the end device over here will have a constant IP address, so that you don't have to worry about this changing. So what we're doing is we're basically drawing a curtain here. And we're saying behind this curtain, don't worry about what's going on. Just keep sending your packets to 1.2.3.4. And behind this curtain, I'm going to worry about what's happening. So as far as YouTube is concerned, they don't care.
All this talk, is it for the data on cell phones, or is it also the same for Wi-Fi?
Wi-Fi is different. So I actually don't know if this is all like cell phone kind of stuff.
Right. Does it have handoffs in Wi-Fi?
I don't know, actually. I mean, Wi-Fi has been around for a while. I'm pretty sure that in the original Wi-Fi specification there was no allowance for handoff. It's possible that it's evolved since then. No?
in terms of being at campus, I'm pretty sure you can keep an IP the same if you move from one access point to the other. But that's only because they have a central authentication for that
I think
anyway.
you
So
can do that.
I think it's still just one router that you're not really moving
That's
between one.
It'd be interesting to try. Like, Wi-Fi, you should change hubs about every couple hundred meters or so. So if you turn on your laptop and walk basically from here back to the computer science building, and you should like just check to see if you still have okay. Here's what you do: go to YouTube, start playing a long file, and walk from here to the computer science building and see if you keep your connection. And if you do, then it's handing you off, and otherwise it's not.
I've done that like Scott.
Yeah.
Doesn't work.
Okay, so
It would be nice.
Because YouTube will buffer it up. So you watch it.
that's right. So YouTube might buffer. That's a good point. Was there a question over here?
So is there any way without closing a session and changing the IP? It's like, can we design it in application somehow?
I'm sure there is. It's just that this is the way that this is called mobile IP, and this is how they do it. So anyway, let's move on. So what we want to do, mobile devices require what's called a topologically correct address. To ensure that packets are routed properly. In other words, when I move from this subnet to this subnet, I can't. I have to change my IP address. I have to acquire a 2.star IP address so that packets will be sent properly from the source to me. Otherwise, I'm unreachable. This guy in this subnet is unreachable because all his packets are being sent somewhere else. So really, what we want is this, and this is figure 3. Really what we want is this source. Here's my 1.star router. And here's my 2.star router. So if this is the 1.star network, and I move from here to the 2.star network, I started with 1.2.3.4, and then I move. I need to acquire a topologically correct address, meaning I need to acquire an IP address within this network. So let's call that 2.2.3.4. Or just to emphasize that it doesn't matter. Like it doesn't matter what the number is. Let's call that 2.5.6.7. Okay, so your computer already does this. Can anyone think of a protocol that does this? Your laptop computer will do this. DHCP, right. So if you used your laptop over here, let's say at home connected to your Wi-Fi router, it's going to get a DHCP address, which will probably be one of the 192.168. Then you bring your laptop to school, you turn it on, and connect it to the York Wi-Fi, it'll acquire a different IP address. So DHCP does this. Anyone know what DHCP stands for? Dynamic Host Configuration Protocol. So DHCP does this.